Okay, so today is all about being able to graph these quadratics that we've been solving for a while now. And in order to be able to graph them, one of the most essential points that you need to find on every quadratic like this for every parabola is a vertex. Okay, so again, just a reminder, the standard form of a quadratic equation is y equals ax squared plus bx plus c. So that we can just give ourselves a reminder of where A, B, and C are. Okay, the graph of a quadratic is called a parabola. Okay, and parabolas look like one of two ways. They can either point upward like that, or a parabola can point downward like that. Okay, so those are the two types of parabolas we'll look at. They open upward and open downward. In this specific point that we're talking about today, the vertex is the either minimum point right here if it's opening up, or the maximum point right here when it's opening down. So it's the technical definition of a vertex is the point at which the graph changes from either decreasing to increasing. So we have change from decreasing to increasing, or increasing to decreasing. So that's kind of the technical version of a vertex. For all intensive purposes, our definition will be either min or max point. Okay, so it's either the minimum or the maximum point of the parabola depending on if it opens upward or downward. Okay, there's a very simple way for finding the vertex. First, we have a formula. So to find the x-coordinate of the vertex, use the formula x equals negative b over 2a. Okay, so x equals negative b over 2a. You'll want to star that, underline it, bubble it, whatever you want to do to make sure you remember that formula, because that is super important. X equals negative b over 2a. So that's our formula vertex, our vertex formula for just the x value. But as you can see, all these vertexes here are ordered pairs. They're not just an x value like our zeros were. They're an x and a y value kind of put together. So then the second point here is important. To find the y coordinate of the vertex, all I'm doing is plugging that in. And I want to make sure and write my vertex as an ordered pair. Okay, so let's practice one together. So I want to identify the vertex for this example 1. Okay, let me zoom in here a little bit. So first I start out by finding the x value. And in order to find the x value, I need a and b. So I'm going to go ahead and identify. I know a is always a number in front of x squared. In this case, that's negative 3. And b is always a number in front of x, which in this case is 6. So I start off with my formula. X equals negative b, so that's going to be negative 6 over 2 times a, which is negative 3. So negative 6 divided by, and then on bottom 2 times negative 3 is negative 6, gives me an x value of 1. So that's only half of my vertex, because remember, a vertex is always an ordered pair. So that's the x value to the vertex. Now I need a y value to go with it. So I'm going to come over here, and I'm going to use this same function that I had, except now in place of these x's, I'm going to plug in my positive 1. Okay, so my function is y equals negative 3, and then in place of my x, I plug in my 1 squared plus 6, and in place of my x, I plug in my 1, and then plus 5. So all I did was use the same function that I was given. Instead of these x's, I'm just going to put in the value I just found, which was 1. And now all I have to do is just work out this math. Make sure you're doing exponents before you multiply. So here I have 1 squared, which is still 1, times negative 3. So that's just negative 3, plus 6 times 1 is 6, plus 5. And then negative 3 plus 6 is 3, positive 3. And then 3 plus 5 is 8. So I get a y value of 8. So then that means my vertex is the ordered pair 1, 8. So every vertex is always an ordered pair. Okay, so that's all it is. You just use this little vertex formula to find the x value, and then once you find that x value, you plug it back into your original function and do the math, and you can find the y value, and then write it as an ordered pair. Okay, all right, so you have 4 try these problems. So go ahead and pause the video, and work out your 4 try these problems on your notes, and then you can go ahead and play the video when you're ready for the answers. Okay, so just looking here. On A, I identify A as 1, B is negative 6. Remember, since the formula is negative B, if B is already negative, I flip it back to the positive 6. So then 6 divided by 2 is 3. I plug in my 3, and I work out all the math and get down to negative 1, so I have 3, negative 1 for my vertex there. B, similar style, A is 1, B is negative 6. So the negative 6 flips back to positive 6 divided by 2 is a 3. I plug in my 3, work out my math, and I get a y equals negative 4. So 3, negative 4 would be my vertex there. C gets a little tricky because A is negative 1. Okay? So my B is 4, so that's negative 4 on top. Over 2 times negative 1, I get an x value of 2. And this is where it gets a little tricky. Since the negative is in the function, the negative goes outside the parentheses. Okay? So remember, I always want to do order of operations. So I want to do exponents before I multiply. So I do 2 squared is 4, and then apply the negative. So that's why I have my negative 4 here. And then I work out the rest of my math and get y equals 9 for my vertex of 2, 9. D is a little bit different from that. Because now when I work out my x value, I get an x value of a negative 1. Now since the negative 1, the negative is in the number I'm plugging in, I do actually square that whole number, so I don't take the negative outside. So this negative 1 squared is positive 1. So that's why you kind of see the discrepancy between this one stays negative and this one turns positive when I square both. Depends on if the negative's in the problem and it's outside the parentheses, it stays negative. If the negative's in the number I'm plugging in, when I square a negative, it becomes positive. Okay, and I get a y value of negative 9 there. So that's the quick and easy method we use for finding the vertex.